In this video, we're provided with a question to find the greatest value in an array, right? We need to find the greatest value in an array, which is stored from memory address 2000 to 2005. And then once we find the greatest number, we need to store the greatest value in the memory location 2000AH. So a few things that we need to consider here. We have an array from 2000 to 2005, meaning there are 6 elements. And we need to find the greatest number. Okay, first of all, let us define a few prerequisites. We'll use the register BC for saving our memory locations. We'll use register D as our counter, and we'll use register H as highest value register, or which means that the highest value is going to be stored in register H. Start with the code. First of all, let us load register BC with the starting address 2000H. After that, we also need to load our counter. Basically, there will be 6 elements, so the count will be 06. And then the highest value will be stored in H. For now, in the beginning, the highest value is going to be 00. What we do is we read the first value, we subtract the value from accumulator with the value in register H, which basically means A minus H. Now if the new value is higher than the existing greatest value, then the result is basically positive. But if it is not, then the result is negative. So we only want to store our result whenever the result is positive, or else we just want to move on to the next location. So I can compare the sign flag. Basically use jump on positive loop. We'll define loop somewhere else. Let's first complete the part where we see, or where we find out that the new number is actually lower than the greatest number that we already have. So what happens now is we need to increase our memory address. INXB will lead this BC pair value 2000 to 2001. Then we decrease our counter, and then we continue this whole operation until and unless our counter becomes 0. So let's jump to, let's not write loop, provide this as start, and the start will be here. Now once we have our greatest number, or once the counter is already done, or we're done with every other value, what we want to do is we want to move our value from register A to register H. We want to store the greatest number in 200AH and then terminate the program. But the program is actually not done here. We've only done the case for where the new value or the reading value is less than the existing value. So new value is less than existing value. Now what happens if the new value is greater than the existing value? I'll continue this here since I don't have any space. I'll continue it here. We define a loop. Basically the program is going to come here. What I have to do is I need to move my accumulator value to the greatest value, since the new value that I've received is greater than the particular value that I have addressed as. So the new value now becomes the greatest value. So I need to do move H comma A, and then continue the same here. INX B DCR D and jump on non-zero start. And then once the counter is done, or if the 0 condition is satisfied now, Then we need to store our result in 200H and then terminate the program. Let me elaborate this a little more with examples. Okay, let me keep this up here and let's draw a line so that we can separate this out. Okay, so we have 2000, 2001, 2002, 2003, 2004 and 2005. Let's say we have 10H, 05H, 01H, maybe say 03H. Okay, let's not put 10 because this is going to be, or maybe I can say I have 11H, 11H here, and then 04H here. Okay, so how will we proceed with this program is, very first we are going to move the address 2000 in BC. So BC will now have the address 2000. Then I will have a value of 06 in D and 00 in H, right? Now at the very beginning we load the value of 2000 in our accumulator. So accumulator actually gets the value 10H. We subtract 10 with 00. The result will be positive. So if the result is positive, the program is going to jump from here to this particular condition, and then we basically move the value from accumulator to H. So E currently has 10. So in our H register we're basically going to keep 10, right? And then we increase our address, which means 2000 becomes 2001 now, and then we decrease our counter. 06 now becomes 05, and then we check if this particular value 05 is a non-zero value. Of course it is a non-zero value, so we go to this particular tag start here. From here we move to this particular tag start here. Now we again load the value from address BC, which is currently 2001 now. So in accumulator we get the value 05H, 05H. Now we subtract 10 and 05. Basically we do 05 minus 10. The result is going to be negative, which means this particular condition is not satisfied. So we move down. The address now becomes 2002 because we have then increased this BC pair data. Then we decrease D from 05 to 04, and then basically moved on to start again, comparing that this is a non-zero value yet. Then again we load the value from 2002 to the accumulator, which means 01 comes to the accumulator. We again subtract it. So 01 minus 10 is again negative. Now again the positive condition is not satisfied, so we increase our counter, which means now we move to 2003. We decrease our register, we increase our memory location, we decrease our register to 03, and then continue it accordingly. When we reach 04 again, we see that we've loaded the value 11 or 11H into the accumulator. We subtracted 11H minus 10H. Obviously the result is going to be positive, which means the program is going to jump from here to this particular loop here. So we move the higher value 11 to H, replacing 10 that we had previously, and then we basically increase the memory address, decrease the counter, and then continue it until the counter reaches 0. Once the counter reaches 0, either we're going to be executing this instruction or we're going to be executing this particular instruction, and depending upon where we are at the current moment, right? Oh, one thing I missed here is that after this particular condition stops getting satisfied, I need to move my highest value from H to A and then only store the result. So this is the complete program that we have here.